So we'll start. So how long to wait? Okay. So we were doing revision in the last class, and we have started with what was DBMS, how was the environment, what was the three-layer architecture, what was the main characteristics of a database approach. Then we were seeing about database users. Then we've seen about advantages of database. So, and we have seen about historical, how the extended database, what was the history behind the database. Okay. So today we'll start with why not to use a DBMS. In which situation should I not use a DBMS? So main inhibitor or a cost of the using a DBMS. So when do we asked not to use DBMS is, so main inhibitor, the cost of using a DBMS, high initial investment and possible need for additional hardwares. So when do we not require DBMSs? High initiative. So suppose now you want to purchase a Oracle. So then there may be lakhs together. So initially you are doing very small project which may cost you 1 or 2 lakhs. So then investing more and getting less profits, in that situations we may not use a DBMS. So the high initiatives, high initial investments and possible needs for the additional hardwares. Overhead for providing generality, security, concurrency control, recovery, and integrity functions. So that's what is why not to use a DBMS. So overhead for providing generality, security, concurrency control, recovery, and integrity functions. When a DBMS may be unnecessary if the database and applications are simple, well-defined, and not expected to change. If there are stringent real-time requirements that may not meet because of DBMS overhead. So when a DBMS may be unnecessary, if the database and applications are simple, well-defined, and not expected to change, if there are stringent real-time requirements that may not meet because of DBMS overhead, if access to data by multiple user is not required. That is what is why not to use DBMS. So why no DBMS may suffix if the database system is not able to handle the complexity of data because of modeling limitations, if the database users need special operation not supported by the DBMS. Next, we see the architecture of the DBMS and what are the different models of the DBMS. So the data model, a set of concepts to describe the structure of DBMS and certain constraints that DBMS should obey. Data model operations for specifying database retrieval and updates by referring to the concept of data model. Operations on the data model may include basic operations and user-defined operation. So that's what here, what is a data model? Data model, a set of concepts to describe the structure of database and certain constraints that the database should obey. Data model operations, the operations for specifying database retrieval. So now you can see WhatsApp, you can see any banking, so where we retrieve the model. So database retrieval and updates by referring to the concept of data model. Operations on the data model may include basic operations and user-defined operations. So that is what data model and data model operations. Then category of data model, conceptual, physical, and implementation. Conceptual, high level or schematic. Data model provide concepts that are close to way many user perceives data, also called entity-based or object-based data model. So that's what is called as a conceptual or a high-level semantic, also called entity-based or object-based data model. Physical, low-level or a internal data model provide concepts that describe details of how data is stored in the database. Then implementation, that is representational data model, provide concepts that fall between the above two, that is balancing user view and some storage details. So that's what a category of the data model. So then history of data model, what is a relational model? The relational model was first person, that's what EF Code, he was the first person, and he is also called as the father of DBMS, because he proposed in 1970 only. That was a model which still we are using. So first commercial system in 1981 and 1982. Now in the general commercial product, DB2, Oracle, SQL Server, Sybase, Informix, all these are the history of data models. Then network model, the first one to be implemented by Honeywell in 1964 and 65, IDS system, adopted heavily due to the support of Codacil. DBTG's report of 1971, later implemented in a large variety of systems, that is IDMS, Cutlinet, now CA. So these are the different net models which were developed by different companies. Then historical data model, the implemented in joining effort by IBM and North American Rockwell around 1965, resulted in the IMS family of the system. The most popular model, other system based on this model, that is System 2K, SASC Inc. So then history of data model, object-oriented data model, several models have been proposed for implementing in a database system. One set comprises model of persistent object-oriented programming language such as C++, example in Object Store or Persistent, and Smalltalk, example in Gemstone. Additional systems like O2, Orion, at MCC, then ITA, SCA, then Iris. All these are the historic of data model. The object relational model. So most recent trends with the informatics universal system server exemplified in the latest version of Oracle, that is 10i, DB2, and SQL Server and system. So this is what we were seeing about a data model. In the same way, now let us see what are the advantages of each model and what are the different advantages of different models. Now, first one, the hierarchical model. Hierarchy means what? All the hierarchical model. So there are different models. Okay. So the advantages of hierarchical model. The hierarchical model is simple to construct and operate or corresponding to a number of natural hierarchies. Organized domains, example assemblies in manufacturing, personal organization in companies. Language is simple. Uses, yes, yes.
Ma'am, could you please share the screen, ma'am? The screen is not visible, ma'am.
Yes,
Yeah,
ma'am. You didn't share the
yeah, you
screen.
should have told me before only, right? You people are, that's,
No, I think for me it's problem.
yeah,
I don't know.
yeah, yeah.
Yeah. Yes, ma'am.
Okay, see, you, yeah, because the other end sometimes we may not be knowing how it is working. Okay, so that's what just now we have started with, why not to use DBMS. So main inhibitor, cost of using DBMS. So the initial investments will be very high, and recovering the database concurrency, if parallel people are using, 1 lakh people or 2 lakh people are using, then recovering that, then integrity functions. So these are when not to use the DBMS. So then we have started with data models. So the data model set of concepts to describe the structure of the database and certain constraints that data model should obey. So that's what you people have started doing programs, 5 programs in the lab, and you'll be knowing how the structure of the database is. And there is some syntax for creating a table. There are some words like create table, table name, how many columns you want, so many columns, and what data type you want to store, what is the size, everything is there. Along with that, constraints also you give, whether it is a primary key, foreign key, unique. So there are so many constraints which we use. That is what your data model. So then data model operations, what we can do on the database, we can retrieve, we can insert, we can update, we can delete. So these are the operations which we can do on the database. Same way here, data model operations. So operations, for specifying database retrieval and updates by referring to the concept of data model. Operations on the data model may include basic operations and user defined operations. Then categories of data model, what are the different categories of the data model? That is conceptual, physical, implementation. Conceptual, high level or semantic. So data model provide concepts that are close to the way a many user precedes data, also called entity based or object based data model. Then physical or low level or internal data model provide concepts that describe details of how data is stored in the computer. Then implementation or representational data model provide concepts that fall between the above two, that is balancing user views with some computer storage details. Then history of data model, that is relational model, proposed in 1970 by E.F. Code, that is IBM, for first commercial system in 1981-82. Now in several commercial products, that is database to Oracle, SQL Server, all these were first developed by different companies based on the concept of relational model. Similarly, network model was also developed by a company called as a Honeywell in the year 1964 and 65. Later, there were different companies where they've started developing different models for with using the same concept called as a network. So the same way, next model was hierarchical model, where this was developed by IBM and North America, where it was in the year around 1965. So later, some more models were being developed, that is object-oriented data model. Several models have been proposed for implementing in a database system. One set comprises model for persistent OO programming language, example as C++, example in object store or persistent and Smalltalk, example. So these were the different models based where they have used some concept called as a object oriented model. So in the same way, relational model, object relational model, most recent trends started with Informatics Universal Server, exemplified in the latest version of Oracle 10G. So now you can see you have downloaded some software, and whether it is which version. So latest versions every year the Oracle companies are releasing, because they are adding some more additional features, and they start releasing a different Oracle products. So it was something have started releasing so many projects. Hierarchical model is simple to construct and operate on corresponding a number of natural hierarchy companies. Languages is simple, uses construct like get, uses a GT, get unique, get next within a patent example. Then disadvantage, navigational and procedural nature of the processing. Database is visualized as a linear arrangement of records. Little scope for query optimization. So the network model advantage, network model is able to model complex relationship and represent semantics of add or delete on the relationship, can handle most situations for modeling using a record type and relationship type. So language is navigational, uses constructs like find member, find owner, find next, within get, etc. Programmers can do optimal navigation through the database. Then disadvantages, navigational and procedural nature of a processing. Database contains a complex array of pointers that threads through the set of records, little scope for automated and a query optimization. Then we see about a schema versus a instance. So schema versus instance, database schema, the description of database include a description of a database structure and the constraint that should not hold on the database. So then schema diagram, a diagram diagrammatic display of a database schema, some aspects of database schema. Then schema diagram, schema construct a component of a schema or an object with the schema, example student and a course. So then database instance, so the actual data data stored okay the actual data stored in the database at a particular moment in time, also called database state or occurrence. So then this is what the schema diagram for the database. Student and course information, course information database, that is student course. You can see here student grade report. All these are student course prerequisite section and a grade report. So in the same way, these are the values which we store in the table. That is student. What is a schema diagram? What are the columns in the student student table? We have a name, a student number, class, and a major. Then the course name, course number, credit hours, and department. Then prerequisites, course number and prerequisite number. Section identifier, course number, semester, year, and the instructor. Then grade report, student number, section identifier, and a grade, that is prerequisite. And courses, these are all the different courses available. Then the section, see in the course, in the course name, introduction to computer science. What is a course number? CS 1310. What is a credit hour? That is 4. What, for which department this course belongs? That is CS. So in the same way, one more course, data structure. And what is a course code? CS 3320. Then what is a credit for that? 4. And what is a department? CS. So discrements, that is course is a math. Then database course. These are the sections where 410 semester, which semester it is. Then year, which year it is 04, and who is the instructor? King. So like this, we enter all the values into the section. So 92 is the section. What is the course number? Which semester it belongs? And which year? And what is the instructor's name? The same way, 102 CS. Then what is a semester? Here we call it as a odd and even semester. So in some other country, they call it as a fall and a spring. Now we sorry. We in our thing, we you can see, you would have studied in your kindergarten. What are the different seasons? Summer, winter, rainy, like this we call. So in the same way, in different countries, they call as a fall and a spring. So in the same way, grade report. So grade report, what it says, that is student number, section, and the grade. So student number. So now you have your USN number. Similarly, they have the student number, that is 17. Section identifier as 112, for which section it is been. Then the grade of that, where okay. So this is about a grade. So where we store all the information about a student number, section, what are the different sections we have. So then what is the identifier? What is the grades? So now even you people will get a grade for that. So the same way, B, C, A, B, C. So like this, we have a grade report. Then prerequisite, that is course number and a prerequisite number. That is, this is how the course number is, and this is how the prerequisite is. That is database that stores student and a course information. Database that stores students and a course information. That is a prerequisites for the schema diagram for the database. That is student and a course information, where student, course, prerequisite, section, and a grade report. So then the prerequisite, this is what the prerequisites are. Database that stores student and a core information. So then the course information, the section information, grade report. So this is grade report. Then for the prerequisites, we have taken a prerequisite. Database schema versus database state. So database state refers to the content of a database at a moment in a time. So initial database state refers to the database when it is loaded. Valid state, a state that satisfies the structure and the constraints of the database. Distinct, the database schema changes very frequently. The database state changes every time the database is updated. Schema is also called as intention, whereas state is called as a extension. So that's what here we call it as a schema state. So now, which state you're? So you're in a third semester. So what is your postgraduate you're doing? You will be saying you're doing a masters of computer application course you're doing. What is your state? So you say what is the first semester marks or grade, what is the second semester marks grade, what is the third semester marks grade, like this you say. So then you know at which stage you are now. So you're at the middle of the MCA. So later you may have 4, 5, 6, 3 more semesters you may have. That's what the state says. So in the same way here also, database states refer to the content of a database at a moment in the time. Then initial database state refers to the database when it is loaded. So valid state, a state that satisfies the structure and constraints of the database. Then distinct, the database schema changes very infrequently. The database state changes every time the database is updated. Schema is also intention, whereas state is also a extension. So that's what here we can see database schema and a database state. So then 3 schema architecture proposed to support DBMS characteristics of program data independence, support of multiple view of database. So then proposed to support DBMS characteristics of program data independence, support of multiple view of database. Then what is 3 schema architecture? So then this is how you can see internal level, conceptual level, and external level. What is the internal level? This is the internal level. These are the stored database. That is how much data, what are the database it is being stored. Then the conceptual schema. So conceptual level, conceptual or internal mapping. That's what we see about a conceptual level. Then the external level. So external and a conceptual mapping, external view, and like this we have so many external views. This is what the end user. That is what a 3 schema architecture. Then internal level, conceptual level, and the external level. So how the database 3 schema architecture is being done. So the same thing what we have seen in the diagram, the explanation of the 3 schema architecture. So defines DBMS schema at 3 levels, that is internal schema, conceptual schema, and external schema. Then internal schema at the internal level to describe physical storage structure and access path, typically uses a physical data model. Then conceptual schema at the conceptual level to describe the structure and the constraints for the whole database for the community of the user, uses a conceptual or an implementation data model. External schema at the internal level to describe the various user views, usually uses the same data model as the conceptual level. 3 schema architecture, that is mapping amongst schema levels, are needed to transform requests and data. Programs refers to an external schema and are mapped by the DBMS to the internal schema for the execution. The component module of a DBMS and their interaction. So stored database. So what is a stored database? What is concurrency control, backup, recovery, and subsystem? Then stored data manager. So that's what input and output database. So then this is a system catalog or a data dictionary. Query and the transaction execution. What are the different components component module of DBMS and their interaction. So we have a DDL statements. That's what you see in your create, commit, rollback. All these are the DDL statement. So what do we mean by DDL? Data definition language. So then for that also we have a separate small compiler, that is a DDL compiler. So then who will be using this DDL? This will be used by a database administrator staff. Along with that, he gives the privileges, whether we should be given a credential full permissions or we should give only limited permissions. That will be taken by a database staff. That is the privileged commands will be given to us. So in the same way, casual user, we may not use every time, only sometimes we may use the database. Then we say a casual user, that is interactive user, query compiler, and query optimizer. So this is what casual users are used, that is interactive query, query compiler, and query optimizer. So along with that, we use a runtime database processor, then store database, concurrency control, backup, recovery, and subsystem, store data manager. That's what here stored data manager is. Then application programmer, application program precompiler, and database manipulation language, that is a data manipulation language. Then the host language compiler, compiled transaction. So this is how we see about a parametric user. What are the application programmers? So now you are the application programs who uses the application. So in that also we have to write a code for it. That is what the application program says to us. So then we next see about data independence. So we have in that logical data independence and physical data independence. The logical data independence, the capacity to change the conceptual schema without having to change the external schema and their application program. Then physical data independence, the capacity to change the internal schema without having to change the conceptual schema. Data independence, when a schema at a lower level is changed, only the mapping between this schema and a higher level schema need to be changed in the DBMS. That fully supports data independence. The higher level schema themselves are unchanged. Hence, the application program need not be changed since they refer to the external schema. That is what a data independence. What are the different languages just now we have seen? So, database management system has approved appropriate language and interface to express database queries and update. So database language can be used to read, store, and update the database in the data in the database. Types of database language. So DBMS language, that is DDL, DCL, DML, and TCL. So what is DDL? Data definition language. So what is DCL? Data control language. What is DML? Data manipulation language. What is TCL? A transaction control language. So we see one by one. What is data definition language? Data definition language, that is DDL, used by the DBA, that is database administrator, and database designer to specify the conceptual schema of the database. In many DBMS, the DDL is also used to define internal and external schemas, that is views. In some DBMS, separate storage definition language, that is SDL, and view definition language, VDL, are used to define internal and external the DBA and database designer to specify the conceptual schema of the database. In many DBMS, the DDL is also used to define internal and external schema, that is views. In some DBM, view definition language, that is VDL, are used to define internal and external schema. Then data definition language, DDL stands for data definition language. It is used to define data structure or pattern. It is used to create schema, tables, index, constraints, etc. So why do we use a DDL thing? So first one, we use to create Yeah, it is used to define database structure or a pattern. It is used to create a schema, database, create schemas, tables, index, constraints, etc. in the database. Using the DDL statement, you can create the skeleton of the database. Data language is information of metadata like the number of tables and the schemas, their names, indices, index, columns in each table, constraints, etc. That is what is called as a data definition language. Here are some tasks that DDL. What are the commands we have in a DDL? We have a create. Why do we use a create? It is used to create objects in the database. So we create a object in the database, then we use DDL. So in the same way, it is used to alter the structure of or it is used to delete objects from the database. Truncate, it is used to remove all records from a table. Rename, it is used to rename an object. Comment, it is used to comment on the data dictionary. So that's how here, so you can see used create, alter, drop, truncate, rename, comment. Create, it is used to create objects in the database. Alter, it is used to alter the structure of the database. Drop, it is used to delete objects from the database. Truncate, it is used to remove all records from the database. Rename, it is used to rename an object. Comment, it is used to comment on the data dictionary. The next one is data manipulation language. So this is also in DBMS languages, one among it. So data manipulation language used to specify database retrieval and updates. So now I want to manipulate or I want to update my database, then we use a DML command. DML command, that is a data sub language, can be embedded in a general purpose programming language, that is a host language such as COBOL, C, or an assembly language. Alternatively, standalone DML command can be applied directly query language. DML stands for data manipulation language. It is used for accessing and manipulating data. Handles, here are some tasks that come under a DML. Select, insert, update,
Hello, ma'am.
delete, merge, explain. Yes, yes,
Ma'am, it has
yes,
stopped sharing, ma'am.
yes.
You stopped sharing, ma'am. Screen is not
ಇಲ್ಲಲ್ಲಪ್ಪ
visible.
ನಾನು ಮಾಡೇ ಇಲ್ಲ ಮೋಸ್ಟ್ಲಿ ಇಂಟರ್ನೆಟ್. ಐ ಶೇರ್ ಅಗೇನ್
Yes.
ರೆಸ್ಯೂಮ್ ಯುವರ್ ಪ್ರೆಸೆಂಟೇಷನ್. ನಾನು ಎಲ್ಲೂ ಇದೇ ಮಾಡಿಲ್ಲ. ಓಕೆ, ಮತ್ತೆ ಇದು ಮಾಡ್ತೀನಿ.
Guys, this is Arjun. Ma'am told like everyone you can leave. Our net is problem it seems.
Okay, Arjun, thank you.